Hi everyone, I'm Anthony Lin, the Application Platform Specialist covering Red Hat ASEAN.
Hi everyone, I'm Jing, Automation Specialist working in Singapore Service Team.
Today we are going to talk about the AI Ops Personal Incident AI Helper. The Personal Incident AI Helper chatbot allows the human operator to interact with it in a natural language. It is meant to resolve incident by identifying the root cause and interacting with different IT resources. In our demo, we have an application that is deployed on the OpenShift cluster that is having some issues. What the human operator will do is to interact with the chatbot to be able to identify the root cause and restore the health of the cluster itself. So this is a very high-level architectural diagram for our demo. The chatbot leverages on solutions such as VLLM for the model inference. We have the Ansible automation platform for tools execution. We have Git for centralized source code management. We have the Model Context Protocol MCP for providing automation services for AI. The chatbot uses large language models such as Qwen and Llama in its backend, and it is able to work in both a disconnected and connected environment. I'm going to hand over to Jing next to talk about the AI workflow.
Hi, this is the Agentic AI workflow. First, user provide the issue description. Agent 1 will snag the most similar happened incident to work out the high-level troubleshooting plan. Agent 2 will generate execution plan based on the high-level plan and available tools. Agent 3 will execute the execution plan step by step. If it is no disruptive step such as check status, Agent 3 will direct me to call MCP. If not, this action will require human approval before calling MCP. For instance, service start, which need human in loop. MCP will execute the Ansible playbook. The result of playbook execution will feedback to the agent 2 to adjust the plan for the next step. When the execution plan is completed, chatbot will ask for the human feedback. Chatbot will start second round troubleshooting or end the chat session.
All right. Thanks, Jing. We're going to do a walkthrough of the demo environment next. Hi. In this part of the demo, we are going to take a look at the demo environment itself. As seen from the earlier architecture overview slide, we have a management hub cluster that is being used to manage the rest of the OpenShift clusters. What is being seen in this screen is the fleet management view of the advanced cluster management component that has been deployed on the hub cluster itself. Git, which is the source code management tool, has been deployed on the centralized hub cluster, and you will be used to house the various Ansible playbooks that will be used by the AI tools later on. The MCP server has also been deployed as a pod running inside the namespace in the hub cluster. The Ansible automation platform has also been deployed using the operator and is running inside the hub cluster so that it can be used to manage and automate any components or tools and tasks needed for all the other remaining clusters that is connected to it. Inside the Ansible automation platform itself, we have various templates that have been created based on the playbooks that have been checked into the Git. So what we have here will be the different playbooks that will be used to detect and resolve issues that we will see inside the actual environment of all these application clusters. In this view, we are looking at one of the application clusters that is being managed by the management hub. The to-do application in this case is in a crash loop backup state. In the next part of the demo, what we will do is to leverage on the interactions with the chatbot to try and identify the problem and fix the issue so that the application goes back to normal. This particular view that we have is the OpenShift AI view. So what we see in this case are the various components of the OpenShift AI that have been deployed on the GPU farm cluster. We can see over here that we have the Quen model that has been deployed and is running. Over here, we have different ability and ways to reach this endpoint. For instance, we have one that's only accessible within the cluster and one that has been set up to be accessible from outside the cluster. We can see over here that we also have set up tokens in order to be able to query the inference endpoint and to get the large language model to help us to identify issues and to be able to use it to help us to also resolve a problem. As can be seen over here, we have been using the chatbot to run different tasks. This means that we are able to very easily monitor the consumption of tokens and that the particular models can also be run in both disconnected and connected environment, since OpenShift can run across multi-hybrid cloud environments. So we'll move on to the next part of the demo next. Okay, now that we have finished walking through the demo environment, we will proceed to the actual demo using the chatbot. This is the Personal Incident AI Helper chatbot UI. What we have done is to integrate it with the Ansible automation platform in such a way whereby only user with valid credentials and access to the Ansible automation platform is able to access and use the chatbot itself. This is to ensure that the appropriate role-based access control is applied to the user who are going to use this particular chatbot. So if you do not have the permissions to perform certain actions in the automation platform, you will also not be able to use a chatbot to perform the same task. So for instance, if a user who only has the permissions to view or to check certain services that is inside the target system will only be able to do the same using the chatbot. He or she will not be able to use it to perform other things which requires more permissions, such as being able to start or stop a service. This is vital and important for enterprise customers, especially those that runs huge enterprise setup with multiple different systems, because we will want to ensure that whoever is using a chatbot will only be able to perform the task that he or she has the permissions to. So in this case, what I'm going to do is to test an invalid user called test1 and to give it a password that does not exist as well. So if I were to do this, what I'm going to get back is an invalid username or password. If I were to use another user that exists within the system, I will then be able to access and enter the system itself. So what I'm going to see in the backend is really log that shows that I have tried to access the system, the chatbot, using an invalid user. And I will also see other entries that talk about login attempt for the admin user which was successful. In this case, the token that is being used by the user will then be retrieved from the system, will then be used by the MCP server to perform toScore so that the Ansible automation platform can perform the required task and automation on the target system. So with that in mind, we will then proceed on to the rest of the demo. So as you might probably remember, what happened previously was that we see a container that is in a crash loop backup state. In this case, it is actually the to-do application that is connected to an external Postgres database that is in a bad state. So what we want to do is to be able to leverage on the chatbot to help us to restore the service to this particular application. And what we have actually caused the current situation is by stopping the services of the Postgres. So what happens in this case is that because the backend database is down, and that's why the container goes into the crash loop backup state. As part of troubleshooting, I will then go back to the AI chatbot and key in the relevant information. So what I've actually stated over here is the name of the application and the external Postgres database IP address, getting the chatbot to help me to check what is going on. What happens in the background is really a few things. If we were to look at what has happened, the customized user input is exactly what we keyed in earlier. So in this case, the advice agent, which leverages on the Quen model, is now looking through the database, which is a vector database that has all the relevant information with regards to incidents that has happened within the organization in the past couple of months and years, for instance. And based on those information, it is able to pull out something that has the highest probability. In this case, the incident with the question on why is the application down and offline, and the verification is to be able to do things like checking the databases, and the solution is to run the DB start tool in order to restore the service. There are other things that was being pulled up as well, which has a lower chances of being the issue that is causing the problem. And hence, what will happen next is that the agents will leverage on this and the other agents to call the right tools that will resolve the issue. So over here, we can see that the implementation agents and the two execution agents will all be involved in the process, just like what was described in the AI workflow that we mentioned earlier in the presentation. In this case, we are asking to proceed. I'm just going to do a very quick check on the database status, and it is then moving on to the rest of the operations, which will determine that we want to be able to run a start DB. What happens in this case is really that we need a human in the loop when it comes to incidents that involve starting of services or stopping of services. And hence, what has to happen in this case is we want to be able to have this human in the loop that will safeguard or make sure that certain things which are disruptive to the service and the system will be guarded against any unauthorized or incorrect execution. So in this case, we have accountability as well as the ability to do audit on who and what has actually happened. In this case, starting of a service. So what we are going to do is that we're just going to click yes as the human operator. And what I will see is that there's going to be a DB start job that is running in the Ansible automation platform the moment I trigger this. This is actually triggered via the MCP server calling the respective tools to start the service, leveraging on the Ansible automation platform. So then what you can see over here is that we now have the service that comes back online, and it does a summary on what has been done in order to restore the service. But in many cases, we know that things are not usually just about a single service down. Different things might be going on, and the user might still experience issues like slow response or other things that may be going on inside the system. So I'm going to just do a simulation in terms of stressing the server with high memory load and just trying to see how the chatbot is able to do further troubleshooting if we deem that the service has not been fully restored or that we are running at a suboptimal level, right? So what I'm doing in this case is that I'm just trying to bump up the utilization of resource inside this particular server and eventually triggering the chatbot to try to resolve the high memory issue and symptoms that is being observed as well. So in this case, what I'm going to tell the chatbot is that, great, the application is now restored, but it's feeling sluggish. So when I key this in, it is going to try to figure things out on what else can be done other than restoring the database service. So we can see over here that it is actually trying to do a ping test because it thinks that the sluggish performance is due to a network latency. We're just going to get it to go with it. So what happens over here is what we have is a Ansible playbook that has been executed in the background to try to get the results of the ping test. So what happens here is that it is able to see that the latency is not too high. There's no packet loss as well. We have actually set a threshold of 30 milliseconds. It doesn't seem to be because of the network latency problem. And this kind of way of troubleshooting is actually very similar to how a human operator will be trying. Based on the knowledge and experience of a human operator, we will try to run through things that we think may be causing the issues, and some of these things could just be like doing a ping test or trying to do some other stuff that we think is useful for fixing the issue. So since this is not the problem, I will say please proceed to find other possible root cause. And what happens in the background is that the chatbot will again try to figure things out. What happens over here is that the other agents will then try to resolve the problem by finding other problems that may be causing this thing. Okay, so we can see that the next most probable root cause is actually related to high memory utilization on the database server, and that is what we actually wanted to do next. So we can see that the memory utilization in this case is actually very high. So it's at approximately 93% of utilization. We have actually set a threshold of 50%, and hence the chatbot is suggesting with the agents behind is to try to run the tools that will free up the memory. So I'm going to say just continue on, right? I'm the human in the loop. I'm actually the one that says, okay, this is a good idea. Let's just go on. And after that, it returns back to say that now we are using significantly less memory and everything is actually going okay. I will then be just looking at this particular application and everything is actually back to normal. All right. Thanks everyone for watching our demo. We hope it is useful. We hope to see you again next time around. Together with Jing, we will look at creating more interesting demos in the near future. Thank you.